number one, and once again, if we don't do all 11 this class, that's fine. The main goal is just to practice a bunch of them, so you're getting more comfortable with the steps. So we're given a function. It's a nice polynomial. And I will post this in a second if you don't have it handy right now. Just try this one, and you can try some of the other ones later. So my main goal is, all right, I'm not going to factor that. I don't even know what's going on right now. It's not factorable. So we're going to go and do the rational root theorem. To do so, the first thing I'm going to do is find the factors of the constant. Now I'm looking, I'm like, oh, 64, really, but it is what it is. So our constant, it would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I think that's it. All right. Yeah, because then 64 is 8 times 8, so 60. And then plus or minus 16. Plus, what was it? 64 divided by 2, plus or minus 32, and then plus or minus 64. I always like, when I get to a problem and there's a larger number, I always get a little bit sad, but it is what it is. Then we do the factors of the leading coefficient. The leading coefficient is just 1. That always makes me happy when I see a 1 as a coefficient or a constant, because then you just got 1. So you can kind of do this part in your head, because to find the actual possible rational roots, you would do constant over coefficient, but basically we're just taking all those constants and dividing them by 1. So basically it's just that same list. But I'm going to rewrite it, because if I divide all those by 1, I just kind of get my list, the same list back. But just to remind myself what I'm doing. It is kind of annoying to keep writing it, but there you go. So remember, possible rational roots is constant over coefficient. But since we're dividing everything by 1, it kind of just stays as that same list. So then from there, you're like, all right, well, I have all these possibilities. I don't want to have to do synthetic division for everyone. That would just be highly irritating. So we can kind of check to see what the factors are by using that remainder theorem. We can plug them in and evaluate. And if it does come out to 0, so if I did synthetic division, the remainder would be 0, then it is a factor. So I just start, once again, this is where your calculator is your friend, right? F of 1, okay. If I do 1 cubed minus 14 times 1 squared plus 56 times 1 minus 64, negative 21, that's out. Okay, let's try F of 2. So once again, I just kind of take out what I just put in. I replace the 1 with the 2. And I thank the good Lord, because that is a 0, which means that 2 is a root. Or 2 is a factor, whatever you want to call it. So hopefully you don't have to go test too many. And once again, technically, I could just go and test all of those to find all the factors, but I don't want to do that. If I had to do all the positives, negatives, that would take me forever. So once you find 1, you can now just do synthetic division and divide that out to see what's left and kind of go from there. So
do you have to test them for all of them?
You just have to test one until it equals 0.
Okay.
Then you can stop the testing and say, now that I know that that's a factor, I can do synthetic division with that.
Okay, so you still have to do synthetic.
Oh yeah, but synthetic division's it's delightful, right? Right? Synthetic division. I love. I'm gonna be honest. Like, maybe this is how you know, like, you should be a math teacher. It's like I like doing synthetic division. It brings me joy in my life. So if you like it, maybe you should be a math teacher too. Bring it down. Multiply. That could be negative 12. Chuck. Negative 24. That would be 32, and that would be. I just messed up a sign. Oh, that's a negative 64. Okay, that makes more sense. 0. I knew that had to be 0, so I knew I forgot something. The remainder has to be 0 if it's a factor. And now we can write that in factor form. We can write it x squared minus 12x plus 32, and then we can factor it. And now you can actually answer the question, which was, what are the roots of this polynomial. Don't forget about the 2. The roots are 2. And then if I find the roots of this, it would be 8 and 4. 2, 4, 8. 2, 8, 4. Okay. So if you want to, if you don't want to do the coloring part, why not? Just like take a brain break for a second. On the back, you just find your answer. So mine's 2, 4, 8. If it's a little bit of a different order, that's fine. So in that section, that looks like kind of like a little piece of pie here. If you wanted to do your little pattern there, you're more than welcome to. If you're just like not in the mood, it is what it is. This is kind of calming. Okay, whatever, I'm not doing that. Now, you're probably saying, I don't want to do all these. Okay, then don't do all of them, but I do expect that you do a bunch of them. Okay, so, you know, that would probably half. I'd be pleasantly happy with half. Once again, when you get to one like number 4, number 7, when you see quadratic trinomials, like we're good with factoring. So if you want to factor that, that's fine. But when you get to some of the longer polynomials, you are going to be doing rational root theorem, focusing on the constant, the leading coefficient, getting your possible rational roots from there, checking to see which one is an actual root, and then you can use symbolic division. Now, eventually, I actually made our quiz the other day, yesterday. Oh, good old Wednesdays, I'm going to miss them. And